Good morning, Algebra students. I hope that you're having a good Wednesday, and we're here to do lesson 13.3. It's more probability, and I think it's actually kind of fun. I hope that you're enjoying learning about this. So let's get started. Father in heaven, I just thank you so much for this day, for your goodness and your grace. I pray for all of my students that you would help them to focus well, to learn and understand these concepts so that they understand probability for one thing, and also so that they're prepared for the future in Algebra 2. And I pray, Father, that they would learn it well enough so that they do well on probability in Algebra 2. And I pray for myself that you'd strengthen me and help me to use the right words so I can be the best teacher I can. In Jesus' name, amen. All right, so let's get started. So I'm going to turn on the overhead and sit down. And this is lesson 13.3. Okay, so this is called Find Probabilities Using Combinations. Now, we already learned on Monday that permutation is events that happen in order. So the big key phrase in permutation is order. Order matters. Combinations is the opposite. It doesn't. So a combination is a selection of objects where order is not important. All right, and there's a lot of different examples of this that will make the definition understandable. So for instance, if you had a drawing for 3 identical prizes, you would use a combination to try to find the likelihood of that because the order doesn't matter. Because they're all the same. So it doesn't matter if you pick first or second or third. If you get chosen, then you're a happy winner. They're all the same. Now, if you had a drawing for 3 different prizes, the order would matter because different things are getting picked. So the chances of getting one thing or another would change with whatever was chosen, right? So that's an example. All right, so we're going to look at some more examples that will help make this clear. So here's number 1. Count the combinations of 2 letters from A, B, C, and D. Okay? So we're going to write them all out. There aren't that many. And then we'll see the difference between a combination and a permutation. It will be quite clear. So let's start with A. If I'm going to pick 2 letters, I could have A and B. I could choose A and C. I could choose A and D, right? So let's say I pick B first. So I could have B and then A, B, C, and B and D. All right, I like to go in order because that helps make sure that I do them all. I catch them all. All right, so if I had C first, I could have CA, CB, and CD. And then if I had D first, I could have those combinations too. So right now I have 12 of them. The problem is that order doesn't matter. So I can cross out one of the items that repeats. All right, so here, like I have AB. That has A and B in it. BA has A and B in it, just in a different order. Order doesn't matter this time, so I'm going to cross one of them out. Here I have AC. I have A and C. Order doesn't matter. CA also has A and C, so I'm going to cross that one out. How about AD? Well, DA is the same. Do you get the idea here? Anything that has the same two things in it, I don't want to repeat because the order doesn't matter. So I have BC here, I don't need CB. I have BD here, I don't need DB. If I have CD here, I don't need DC. So then I end up with only half of them, and there are 6 combinations. All right? For A, B, C, and D, choosing 2. Okay, so I want you to try that. So I want you to go ahead and do this OIO. I want you to count the combinations from the letters A, B, C, D, and E. Okay, so go ahead and do that. Now remember, order doesn't matter. So you can pause the video and we'll come back in just a moment. Okay, so let's write all these out. Let's see, I have AB, AC, AD, and AE. And then for B, I have BA, BC, BD, and BE. And for C, I have CA, CB, CD, and CE. And D, DB, DC, and DE. And finally EA, EB, EC, and ED. All right, so there's a total of 20 there, but I'm going to cross out the ones that repeat. So I don't need this one. I don't need this one. Let's see, DA. I have AD, EA. Do I have that? Yeah. All right, BC, CB right here. DB, BD, EB, BE. Just cross out one of them every time. And let's see how many I get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 combinations. You can see how it's cutting it down quite a lot. All right. Now we have a formula for this. And here it is. We're going to have C for combination. N and R equals n factorial over n minus r factorial r factorial. So that's a little different than the last time. There's more in the denominator. So that's going to make you cancel out more, and that's a good thing. All right, so n is the number of the combinations of objects, and R is the number chosen or taken at a time. Okay, so let's do an example using this formula. We want to figure this out using the formula. What does that mean? Okay, that means I've got I've got 4 objects to find the number of combinations. And I am choosing 2. All right? That's what it means. Now let's solve it. So I've got n, so I have n factorial up here, just putting the numbers in the formula, 4 minus 2 factorial times 2 factorial. Okay, so let's work that out. I have 4 factorial over, I'm going to subtract here, and I get 2 factorial, 2 factorial. So when I work that out, I get 4 times 3 times 2 over 2 times 1, 2 times 1. All right? So then, what can I cancel out? These two cancel, and then the 4 and the 2 reduces, so I end up with 2 times 3, which is 6. All right? And I would have had 24 over 4. Okay. All right, so that's how it reduces. So there would be 6. That's like our example of A, B, C, and D taking 2 letters. So it works out to be the same. Okay, let's look at a word problem. So you order a sandwich. At a restaurant. You can choose two side dishes from a list of 8. How many combinations of side dishes are possible? So again, I'm going kind of fast, so feel free to pause this if you need to catch up with what you're writing, or rewind it. All right, so it doesn't matter which side dish I choose first. So order doesn't matter, so that's how I know I have a combination. So the number of items I have is 8, and I'm picking 2. So my combination is going to be C to the 8, 2. So now I'm going to do 8 factorial over 8 minus 2 factorial over 2 factorial. And that works out to be 8 factorial over 6 factorial, 2 factorial. So you see that the math really isn't very hard. It's just the concept, understanding the concepts. So this works out to be 8, 7, 6, 5, 4, 3, 2, 1 over 6, 5, 4, 3, 2, 1 times 2 times 1. Okay? So now let's see what we can cancel. Quite a bit actually. So 6, 5, 4, 3, 2, 1 right there. And then I can cancel out and reduce the 8 and the 2. So 4 times 7 is 28. So there's 28 different combinations of side dishes. Who would have thought, right? How many different ways you can pick things. I have to say, when I go to KFC, it's a guilty pleasure. I love their fried chicken, and their macaroni and cheese is just the best. And I think it's really popular, even though you can have up to 28 different choices. People are picking the macaroni and cheese, okay? All right, so let's go on to number 4. I'm going to read it out loud, and we'll take some notes. A yearbook editor has selected 14 photos, including one of you and one of a friend. So we have 14 photos of who? You and a friend. So there's 2 people to use in a collage for the yearbook. Ooh, that sounds like fun. The photos are placed at random. There is room for 2 photos at the top of the page. So room for 2 photos. And it doesn't matter which one. So order doesn't matter. Okay? What is the probability that your photo and your friend's photo are the two placed at the top of the page? Okay? So we have our n is 14, and I'm picking 2, so that would be 2. Now it's of you and a friend, but it doesn't matter who's first. So it could be you and then the friend picked randomly, or the friend then you. So do you see how there's 2 possibilities there? Order doesn't matter. Okay, so we've got C of 14 to 2, which is 14 factorial over 14 minus 2 factorial times 2 factorial. Okay, so this works out to be 14, 13, 12. Now I'm just going to do that. I'm going to leave it at 12 factorial because what's 14 minus 2? It's 12 factorial. All right, so look at, instead of writing it all out now, I've gotten good at this. I understand it well enough. I can do a little bit of shortcuts. So I'm going to just cross those out. And then 14 and 2 I can cancel to 7. And 7 times 13 is 91. So there are 91 possible outcomes. Sorry about that. I don't know who is calling me, but they'll leave me a message. Okay, so the other question is, what is the probability that that you and your friend will be chosen? So what is the probability that you and your friend's photo are chosen? Okay. Oh, I'm so sorry. I missed it. There's 14 photos. Okay. It's 14 photos of people. And 2 of them are you and your friend. You and a friend are 2 of them. I think that was a little unclear. Okay, so let's go back to this. So you've got 14 photos of different people. So remember, probability is favorable out of possible outcomes, right? So what's favorable? Favorable would be picking you and a friend. So out of 14 photos, either picking you first or your friend first would be what you would want. 2 possibilities. And what are our possible outcomes? Well, we used our combination to figure that out. So it's going to be 91. So it's 2 out of 91. That's the chances, excuse me, that you and your friend are both going to be picked. Not very good chance. I think I would want to just talk to the editor if I really want my photo there. I think I would have a little bit more chance there. Okay, I'm going to give you an OIO. And I'm going to read it to you, and then we will write down the important information. You sing in a chorus after school. The director will choose at random 2 songs out of 5 for the chorus to learn to sing. You can use combinations to help find the probability that the director will choose your 2 favorite songs. Okay, so we've got a choir director. The director is going to choose 2 out of 5 songs for the chorus to sing. Okay, now, so remember, I'm going to let you try that. It's not just 2 out of 5. Remember, because you can choose one and then choose another. So it's not 2 out of 5. You're doing 2 choices. So go ahead and try that, and we'll come back in just a moment. Okay, let's go over this. So my N is going to be 5, and I'm picking 2 out, so that's R, right? So my combination is going to be C5 to the 2. And that works out to be 5 factorial over 5 minus 2 factorial, 2 factorial. So then that works out to be 5 times 4 times 3 factorial over 3 factorial times 2 factorial. Now, why would I stop at 3? Because down here I can see that 5 minus 2 is 3, so I can just cross these out. And then the 4 and the 2 will cancel out because that's 2 times 1, right? Those all cancel out. So I end up with, hang on, I wasn't supposed to, oh yeah. That becomes 2, so 5 times 2 is 10. So there are 10 possible combinations of choosing 2 favorite songs. So that is possible. Now what's favorable? What's favorable, remember probability, is favorable out of possible. So I want my 2 favorites. So favorable is 2 and possible is 10. So it works out to be 1/5. You have a 20% chance of getting the 2 songs. Now, do you see how this is different? If we had just gone with 2 out of 5, which is what you would think, it would be 2 out of 5 becomes 40%. 40% chance of picking 2 out of 5. But because they're chosen one at a time, and because order doesn't matter, it is reduced, but it's only reduced by half. So it becomes 1/5. That's why the combination is important, okay? So that's it, and we're going to be done with this lesson now. I'll give you homework, and I hope you have a great Wednesday. Bye now.